Now, first we will see a simple problem to determine the transfer function V2 upon V1. So this we have to find the relationship between V2 and V1 from this diagram. So here all the values are given. You can see all the values are given in ohm, farad, like this. And here it is given that I2 is 0. Now first thing you have to convert this network into the S domain. So S domain में 1 is same 1, then 1 farad is 1 upon Cs. So C का value is 1. That's why 1 upon S. Similarly, here for 1 farad, it will be 1 by S. And these are the assumptions that we made here. These are the assumptions. This node having voltage VA, this node having voltage VB, and this is the current IB which is flowing through this branch, and this is I2, like this. Since it is given that I2 is equal to 0, see, V2 is here and V1 is here, and we have to find the relationship between V2 upon V1. So it is a transfer function, voltage transfer function. So we have to go from right to left. We have to go in this way. So first we try to write VB in terms of V2. Then we have to try to write VA in terms of V2, like this. So now I2 is equal to 0 is given. So this is an open circuit. So that's why the current flowing through this is same as IB, and there is no element here. So we can say V2 is same as VB. So first thing we can write from the observation, VB is equal to V2, because there is no element and the current is 0. Current flowing through is 0 and there is no element. So that's why we can say V2 is equal to VB. That is, V2 is nothing but voltage across this capacitor 1 by S. So first thing we have to write VB in terms of V2. So this is our first step. And then since IB is coming from this VA, so then we have to write this IB in terms of V2. Now IB, here is also IB is flowing. And now in case of nodal analysis, we can say VB, the current flowing through this is IB is nothing but VB upon 1 by S. VB upon 1 by S. Because IB is the same current flowing through this branch. So that's why flowing through this capacitor. So voltage upon impedance. So VB upon 1 by S. So it will be S into VB. And VB is nothing but V2. So that's why we can write IB in terms of V2. So IB is equal to S into V2. So in this way, we have written IB also in terms of V2. Now our next assumption is VA. Now all of you know that now you know that this nodal analysis, sorry, Suppose this is V1 and this is V2, and current is flowing like this, and this is R1. Then because and I1 is flowing through this. So because of this current, polarities will be positive here and negative here. So we can write I1 is nothing but V1 minus V2, V1 minus V2 upon R1. From nodal analysis, we have written these equations. Okay, so I1 I1 into R1 is equal to I1 into R1 is equal to V1 minus V2. And I can write then V1 is nothing but I1 R1, I1 R1 plus V2. So all of you know this. So V1 I can write I1 R1 plus V2. So in the similar case, in the similar way, I can write this VA and the current IB having this polarity, and this is VB. So I can write VA is equal to 1 into IB plus VB, like this. V1 is equal to I1 R1 plus V2. So V1 is nothing but I1 R1 plus V2. So in this way, I can write VA is equal to IB plus VB. IB matlab 1 into IB plus VB for this particular branch. Have you understood this? So this is the next, from next observation, we can write VA is equal to 1 IB plus V2. Have you understood this? Hello?
Yes, sir.
Okay. So in this way, from for our next assumption, that is VA. VA is our next assumption, and we have to write VA in terms of V2. So VA is 1 into IB plus V2, and IB, you know, IB is SV2. So SV2 plus V2, and so take the V2 common, so it will be S plus 1 V2. So here we have written VA in terms of V2. Now our next target is V1. So V1 also we can write in this way. Then we have to write I1. So I1 is equal to, wait a minute. Now we are writing I1 in terms of V2. So assume If you can assume all the currents are leaving, or just assume the current is flowing from this in this way. Okay. So let's say this is IA. So if you apply KCL at this node, then incoming current is equal to outgoing current. You can say, so I1 is equal to IA plus IB, IA plus IB. If you apply KCL at this point, IA plus IB. And what is IA? IA is nothing but VA upon 1 by S. So this term, VA upon 1 by S. And what is IB? IB is, we have just calculated IB. IB is nothing but SV2. So we can directly write SV2. And VA into 1 by S is S into VA. So plus IB. And VA is also we have calculated in terms of V2. So here VA is nothing but S into S plus 1 into V2 plus SV2, that is IB. And take V2 common, you will get this S square plus 2S. So here we have written I1 in terms of V2. Now V1 is left. So in the same way, like this VA, we have written VA is equal to 1 into IB plus VB. So in the same fashion, we can write V1 is equal to 1 into I1, 1 into I1, 1 into I1 plus VA. So in this way, we can write the equation for V1, 1 into I1 plus VA. VA we know in terms of V2, S plus 1 V2, and I1 is also we know S square plus 2S into V2. So in this way, we can write this, and finally we get this S square plus 3S plus 1 into V2. And finally, if you rearrange the terms, you will get V2 upon V1 is equal to 1 upon S square plus 3S plus 1. So this is the relationship between V2 and V1. Transfer function. This is a transfer function, output upon input. You can say voltage transformed at one port to the voltage transformed at another port, ratio of. You can also call it as gain, output voltage upon input voltage. This is a voltage transfer function. And here you get the equation for this network. And this equation shows this is the network equation. So have you understood this problem, all of you?
Yes, sir.
Okay. So just remember this. These are the assumptions that we made. VA, VA, IB, and VB. These are the assumptions that we made, and we have to write these assumptions in terms of V2, and we have to go from right to left. So in this way, first we write VB in terms of V2, then we write IB in terms of V2, then we have written VA in terms of V2, then we calculate I1 in terms of V2, and finally then we write the V1 in terms of V2. So from right to left, you have to analyze this circuit. This is very important question from your university exam point of view. If theory question will be there, then one problem from this is definitely there. Such type of question asked every year in university exam. If you see the previous question papers. Now we will see the next problem. He, in this problem, we have to find these three ratios: V1 upon I1, V2 upon V1, and V2 upon I1. So these three uh, ratios, relationships that we have to find. And here, if you see, the components values are given in their units: 1 Henry, 1 Farad, like this. So first we have to convert this into S domain. S domain. So this will be LS, and this will be 1 upon CS. And value of C is 1. Here value of L is 1. So only S will be there, and only 1 by CS will be there. And these are our assumptions: VA, IB, and VB. These are our assumptions. And I2 is equal to 0 is already given. So in the same way, we have to follow the steps. We have to write VB first in terms of V2. Then we have to write IB in terms of V2. Then we have to write VA in terms of V2, like this. So same, there is no element in this, and I2 is also 0. So we can write VB is equal to V2. So first is VB is equal to V2. Then next is IB. Now same IB, I2 is equal to 0, then no current will be flowing in this branch. So the same IB will flow through this. So that's why we can write IB is nothing but VB upon 1 by S with respect to ground. So AB is VB upon 1 by S, and VP is nothing but V2. So this SV2. Now next is VA. Now VA is nothing but IB into S plus V2. Since VB is nothing but V2, so we have directly written V2 here. Now what is IB? IB is nothing but SV2. So here SV2 is substituted, and finally we get VB is equal to S1 square, S square plus 1 V2. So here we have written VA in terms of V2. VA in terms of V2. Now, in the similar way, I1, you have to apply KCL here. So this is one current flowing through this. So let's say this is suppose IA. Then we can write I1 is equal to IA plus IB. So IA is nothing but VA upon 1 by S. So this will be VA upon 1 by S, and this is IB. And we know IB, value of IB is SV2. So value of IB is SV2, and value of VA is S square plus 1V2. So here also we have written I1 in terms of V2. I1 in terms of V2. So here S square plus 3S into V2. Now, what is your target? You want V2 upon V1. You want V2 upon I1. And you want I1 upon V1 upon I1, like this. So, if you see, you get V2 upon I1 here. V2 upon I1. You can see this is I1 and this is V2. So from this, you will get the V2 upon I1. V2 upon I1 that is required. You will get from this equation. So it would be V2 upon I1 is nothing but 1 by this S cube plus 2S. S cube plus 2S, like this. So here in this step you get the one equation, that is V2 upon I1, which is required in the problem. Now we can move to the next part, that is V1. Now try to write V1 in terms of V2. So V1 is equal to SI1 plus VA, and I1 just we have written in terms of V2, so that we have to write. So S into I1 and S square, and VA is nothing but S square plus 1 into V2. So if you take V2 common, then you will get this equation. Again simplifying this, you will get S square plus 3S square plus 1 into V2. Now here you can say this V1 and V2 is there. So you can write from this equation V2 upon V1, the ratio of V2 upon V1. You can write from this, which will be 1 upon S raised to 4 plus 3S square plus 1. This is your first required equation. This is second. Now you want third, that is V1 upon I1. So how you will find V1 upon I1? So here V1 upon I1 we have already find out. No, that is V2 upon I1. Now V1 upon I1 we have to find. So here we have V2 upon V1. Here we have V2 upon I1. So from this two, we can easily find out V1 upon I1. take the ratio of V2 upon I1 upon V2 upon V1. So this V1 will go up, V2 get cancelled, and this I1 will be in denominator. So this will be V1 upon I1. If you take the ratio of these two, then you will get V1 upon I1. So have you understood this second problem?
Yes, sir.
Now here also you have to find V2 upon V1. Now here you can say this node is only one node. Since there is no element is connected, so both points are same, but the currents are different through this and through this. So this current gets divided into these two parts, and I2 is 0 is given here. So here assumptions they have made, IA is flowing through 2S, and the current flowing through 1 farad is 1S, and this is IC and IB. But this VB and VC both are same. VB is equal to VC. Both are same because this is the only same, only line is there. So these 2 points are same points, and which is equal to V2. So this node voltage at this node is V2 actually. Now we have to find IA in terms of V2. So IA is nothing but IB plus IC. If you apply KCL at this node, if you apply KCL at this node, then this is IA, this is IB, and this is IC. IA is equal to IB plus IC. Incoming current is equal to outgoing current. So if you apply nodal analysis here, you will get IA is equal to IB plus IC. So what is IB? IB is current flowing from node voltage VB to the ground. So VB upon 1 by 1S, and here V2 upon 1. So this is nothing but V2 only. I have written here. This is nothing but V2. So here we have written this is V2 upon 1 by S plus V2 upon 1. So here we get this IA in terms of S plus 1 into V2. Now in the similar way, we have to write VB in terms of V2. So VB is nothing but 2S into IA plus V2. This is V2. So it will be, we have just written the value of IA, so we have to substitute here. And then we can write VA in terms of V2. And after that, we have to write I1 in terms of V2. So I1, and let's say this is Ix. So I1 is equal to Ix plus Ia. I1 is equal to Ix plus Ia. And Ia we have just converted into V2. So Ia is S plus V2. And Ix is Va upon 1 by S. So this is Ix and this is Ia. After substituting all the values, you will get the I1 in terms of V2. And the last is V1. Now V1 is equal to 1 into I1 into Va. And we have just calculated the value of I1 and Va. So in this way, after solving this, you will get this. And after rearranging the term, you will get this. Very simple problems are there. For 5 marks to 8 marks, it can be asked. Have you understood this problem?
Yes, sir.
Okay.